Today we are diving into equivalent ratios. So the first thing to remember that we've talked about this whole time is ratios are constant and never change. And we saw that earlier with the ratio tables, how you were adding the same amount of sugar or the same amount of flour each time. So our ratio table showed us that the ratio of sugar to flour was 3 to 5. And that told us that for every 3 cups of sugar that we added to a recipe, 5 cups of flour were added. So plus 3 cups of sugar plus 4 cups of flour plus 3 cups of sugar plus 5 cups of flour. So we can actually use this ratio table to help us find equivalent ratios and to recognize equivalent ratios. And before we continue, equivalent we've used in the past when we were doing equivalent expressions. Equivalent just means equal. They're equal to each other. So going back to our example, when we have a ratio, we can write it as a fraction. So we can write it as 3 to 5 or 3 over 5. And equivalent ratios, if they can be written as fractions, then we can just use them as equivalent fractions, which we've been working with since, I think, 4th grade. So if you remember from past grade levels, to create an equivalent fraction, all you have to do is multiply or divide the numerator and the denominator by the same amount. So for example, if we multiply 3 and 5 by 2 and 2, we get 3 times 2 is 6, 5 times 2 is 10. We get 6/10. Let's see if 6/10 is in our ratio table. It is. So 6/10 is in our ratio table. So that confirms that this is an equivalent fraction or an equivalent ratio. So then, if we were to multiply 3 and 5 instead of multiplying by 2, oh, my eraser was very big. I was not expecting that. Okay, if we already multiplied by the 3 and the 5, each by 2 to get 6/10. Now, if we multiply by 3 and 3, we would get 9. 3 times 3 is 9. And 5 times 3 is 15. So we get 9/15. And is that in our ratio table? It is. So we know that's also an equivalent fraction or an equivalent ratio. So this is a way you can check to see that you didn't make an error in your ratio table, is to make sure if you set those as fractions and they're all equal, then you know your ratio table is correct. You can also work backwards. You can take a look at the ratio table and say, well, I see 12 cups of sugar to 20 cups of flour, so that as a fraction is going to be 12 over 20, 12/20. And then as we learned last week, there are many different ways to write a ratio, not just as fractions, but also with the colon and the word to. So we can write these with a colon. So 3 to 5 is equal to 6 to 10, which is equal to 9 to 15, which is equal to 12 to 20. So 3 to 5 is equal to 6 to 10, which is equal to the ratio 9 to 15, which is equal to the ratio 12 to 20. And all of these ratios are going to be equivalent to the original starter ratio. So sometimes you will get a ratio such as maybe like 36 to 60. And they're going to ask you, is it equivalent to 3 to 5? And then you have to figure out, okay, what do I need to divide by to see if it works? Well, 36 divided by 12 is 3. 60 divided by 12 is 5. Since they're divisible by the same number, and it gets us down to the ratio, that exact ratio, then we know they'll be equivalent. All right, let's do some examples. So in your work today, it's going to give you a few ratios and then ask you to write at least three equivalent ratios for each ratio, and then make sure you label your ratios because we need to know what the numbers stand for. So this first question says there are 3 boys for every 4 girls in the 6th grade. You can start by writing that as a ratio, 3 to 4. And then now here's your choice. Do you want to double each number? Do you want to triple each number? How are you going to keep it equivalent? So most people like to start by just doubling each number. So 3 times 2 would be 6. 4 times 2 would be 8. So 3 to 4 is equivalent to the ratio 6 to 8. Or you may decide to multiply each one by 3. By 3 and by 3 for your 3 to 4 ratio. And then you get an equivalent ratio of 9. 4 times 3 is 9 to 12. You might get, let's see, if you have the 3 to 4 ratio, maybe you want to multiply by 10 and 10. That's easy. So 3 times 10 is 30, 4 times 10 is 40, and all of these ratios are equivalent. So this is one way of writing your equivalent ratios. And now I'm going to show another way for example 2. So just like in the beginning part of the video, the notes, you can use a ratio table to help you out. So for every 6 shirts sold, a store sold 10 pants. Let's set up a table. We are comparing shirts to pants, and that's a 6 shirts to 10 pants, 6 shirts to 10 pants ratio. And then from here, you can use the ratio table to create your equivalent ratios. So 6, adding 6 each time, adding 10 each time down here. So 6 plus 6 is 12, 10 plus 10 is 20. 12 plus 6 is 18, 20 plus 10 is 30, 18 plus 6 is 24, 30 plus 10 is 40. So I can stop here because it said at least 3 equivalent ratios. Let's just go one more, 30 and 50. So then I will write each of these ratios because this is an equivalent ratio. This is an equivalent ratio. This is an equivalent ratio. This is also an equivalent ratio. I'm going to write all of those off to the side. So we have 12 to 20, 18 to 30, 24 to 40, and 30 to 50. So we've got 4 equivalent ratios for this one. The last way that you can write equivalent ratios is as fractions. So for example, for this last problem, it says Alex reads 5 books every 3 days. So 5 books, 3 days, writing it as a fraction. And then from there, you can use your past knowledge to create equivalent fractions or equivalent ratios. So 5 times 2, 3 times 2 would give you 10 over 6. Now, if you want to double that again, you can and do 20 over 12, or maybe you wanted to multiply by 3 instead. 5 times 3 would be 15, 3 times 3 would be 9. So these are also equivalent ratios. Now, something I did not do that you need to do, otherwise things are going to get confusing because these are just numbers. You need to label each ratio. You need to label each number. So if I go back to number 1, I need to say that we had 6 boys to 8 girls, or 9 boys to 12 girls, 30 boys, I'm running out of room, to 40 girls. And the same thing with all of these. They're not just numbers. Ratios represent something. What does the 12 stand for? What does the 20 stand for? You need to include your labels like I did here for the 5 books over 3 days. So in your classwork today, make sure you include your labels. Otherwise, you will not receive full points. We need to make sure we are communicating what those numbers represent. Make sure you ask questions, and I hope you all have a wonderful day.